Now I will describe immunization strategy of a bond portfolio and formation of a stock portfolio by constructing efficient frontier and capital market line. Let's start with the first part. To follow immunization strategy, you should know what duration is and how it is calculated. Also, you should know how to calculate present value of the bond and internal rate of return of the bond. I want to emphasize that not with any assets the immunization strategy can be followed. There are two main assumptions. The first one, that bonds should have different maturities, and the second one, the internal rate of return of the bonds should be close. Also, I will assume that assets are infinitely divisible and infinitesimal amount of money can be invested in any asset. To start, it is necessary to choose the appropriate way. Use bonds with close ERR and different maturities, and then choose the investment horizon which should lay between minimum duration and maximum duration of the bonds included in the portfolio. Or you choose the investment horizon and then choose the bonds according to your investment horizon. To my mind, the first way is easier, so I will use it. Let's turn to our Excel file. Let us choose the bonds. I will use the Moscow Exchange. For example, let's take two bonds. First, bond of the Bank Odkritie with coupon frequency 2, maturity date on 12th of July 2022, and face value 1,000 rubles. And the second bond of the Eurasian Bank with maturity date on 10th of January 2023 and the same coupon frequency. To determine the investment horizon, I need to obtain current spot rates for each period of coupon payment from Moscow Exchange. As our bonds have the same dates of coupon payments, I need to obtain current spot rates only for each period of the coupon payment. So here are our spot rates. Also, I need to calculate target value of the portfolio using my investment horizon and spot rate for this particular investment horizon. In my example, it is equal to 109,063 rubles. With this value, I will compare the value of my investment portfolio when it will be sold. Now I can move to calculation of the weights of bonds in the portfolio. For this, I need to solve a system of two equations. The first equation. The sum of weights of bonds in the portfolio should be equal to 1. And the second equation, the weighted average duration of the portfolio should be equal to my investment horizon. It is calculated as the sum of multiplication of weight of the bond in the portfolio multiplied by its duration. So, as you can see here, are my weights of the bonds in the portfolio. After this, I can recalculate my portfolio to a particular bond, future cash flows from which will correspond to my portfolio cash flows. So here is the present value of future cash flows, and here is the sum of these cash flows. This sum will be used in repacking the portfolio in the future steps. The next steps are identical to the first. You should repack your portfolio each time when you receive coupon if the spot rate is changed. If the spot rate doesn't change, for example, this value would be equal to this value, you should just invest your coupon which you received in this period by this spot rate for the remaining period of the investment. After all the packings of the portfolio and when it is finally sold, I get its value, which I should compare with the target value, which I calculated before the immunization strategy. As you can see here, the final value is equal to 109,225 rubles, which is more than the target value I calculated at the beginning, so everything is correct, and the immunization strategy was followed correctly. Now I will describe formation of a risky asset portfolio by constructing efficient frontier and capital market line. For this task, I also need to obtain data, and I decided to take it from Moscow Exchange. To simplify my example, I decided to take 2 shares. However, this portfolio can be constructed with any number of stock. So let's look at our example. I decided to take a Transport Metallurgy company and Rospatskaya. They all are listed on the Moscow Exchange. To use classical Markowitz portfolio theory, I need to obtain an index data with which I will compare my assets. For my example, I decided to take IMORX, as it represents the overall Russian market. The next step is calculation of variance-covariance matrix. I want to emphasize that it is calculated using the logarithmic returns to reduce the volatility. This matrix is further used in calculation of efficient frontier coefficients and estimation of the portfolio volatility. The next step is calculation of the estimated returns of my assets. For this example, I will use the simplest model, CAPM. Now I can move to construction of the efficient frontier. The formula of the efficient frontier in case of two assets will have the following form. So here it is. The coefficients A, B, and C can be calculated using the estimated return of the assets and various covariance metrics. Here you can see the efficient frontier of my portfolio. The y-axis represents the estimated return of the portfolio, and the x-axis represents the estimated risk of the portfolio. Now I can proceed to the construction of the capital market line. For this, I will need to maximize the Sharpe coefficient, which will be the tangent of this line. The maximum Sharpe coefficient will give me the coordinates of the point when the capital market line would intersect with the efficient frontier. So here are the coordinates of the first line with the risk-free rate equal to this, and the second point with the risk-free rate equal to 6.5%. These coordinates give me the optimal allocation of capital into my assets according to the Markowitz optimization model. As you can see, we get a different allocation of assets according to the Markowitz optimization strategy due to the fact that capital allocation line depends on the risk-free rate. So for different risk-free rates, you will get different points. I want to emphasize that none of these portfolios would be optimal for risk-averse investor. Such type of investor should invest in the portfolio which represents the vertex of the parabola. Also, you can move alongside the efficient frontier and choose any portfolio corresponding to a particular investor risk appetite. But this portfolio will be effective but will not be optimal according to Markowitz optimization strategy.